Okay, for number 100, it's a definite integral, and I'm kind of curious what the result's going to be. And probably what I would do in this one over here is just looking at it. There's not much I could do with it. But I'm going to multiply top and bottom by the conjugate of the bottom, and hopefully something works out nice. Let's write that down for you. Is this going to be 1 plus sine x? 1 plus sine x. Oh, you know what? I just copied the wrong problem. Just noticed it. That's plus. So multiply by the conjugate, 1 minus sine x. 1 minus sine x. Now granted, it does create a problem. I'll tell you what the problem is going to be. When I do that, the limits really, I make it improper. Because at pi over 2 now, 1 minus sine x is going to be 0. But let's worry about that later. Let's see if this goes anywhere with the problem. So you get 0 pi over 2. You get 1 minus sine x dx. And the point of multiplying the conjugate, you get 1 minus sine squared in the bottom, which is cosine squared. All right? So I'm going to keep doing this thing over here, and I'm seeing some things. 1 over cosine squared is going to be secant squared. And I'm being somewhat sloppy in the writing of this over here. And what I mean by that is I'm not putting the limit down, and I probably should do that. And then it's going to be minus sine x over cosine x. Cosine squared, sorry. All right, let's see if we met the milestone without the limit, by the way. Was able to get here. I did get here. All right. I do want to point out the reason I'm writing this down, which I think you should do, is by doing this, you made the integration improper. And that's why I'm writing that down over there. All right. Now, do I know the antiderivatives of secant squared? I do. It's going to be the tangent x. All right. These are limits going to be a to 0. 0 to a, I mean. All right. The other guy I want to point out, I just put it aside for you. Do that's minus. I would let u equal cosine of x. What's du going to be equal to? Minus sine x dx. So this guy's pretty simple, actually. And what do you get over there? You get 1 du, and at the bottom you get u squared. All right? So how do you do that? Well, it's going to be u to the minus 2. Let me write that down for you. You increase it by 1, so it's minus 1. You're going to divide by minus 1, so you get, basically 1 over u, so it's going to be 1 over cosine. I definitely do see that. That's written over here. All right? Let me get my eraser out. Erase this, kind of baby work over here. I'm still looking at my typeset work at this point. I'm meeting milestones. And the milestone we're at is right over here now. Right? Get my highlighter out, and I'm going to write down the limit. How do you do that? Let's go through that. And that's going to be the limit as a goes to, let's write this down, pi over 2 from the left side. And there's going to be tangent of a. Minus 1 over the cosine of a. Don't panic yet. And then it's going to be minus the tan of 0 minus 1 over the cosine of 0. All right. A little complicated, I realize that. But I want to point out that, this second evaluation over here looks relatively simple to me. It's just simply minus 1. All right, I'm going to write that down for you. The limit's a little more complicated, though, isn't it? And let's take a look at that. And I got, a little competition going on over here. So let's put this down. So it's going to be plus the limit as a goes to pi over 2 from the left side. And I'm going to simplify this a tiny little bit. So it's going to be cosine A. And on top, what are you going to get? You can get sine of A minus 1. There's a point for writing it down that way. So if I were to do the limit there, what would I say? The top, if I'm going to pi over 2, right, would be 0. And the bottom, oh, I could use L'Hopital's rule. So minus 1 plus the limit as, let's see. You know what? It's not minus 1, it's plus 1. Sorry about that. Because cosine of 0 is going to be 1, and it's minus a minus 1 plus 1. Tan is 0, 0. So L'Hopital's rule. And A goes to pi over 2 from the left. The derivative of the bottom, this with respect to A, by the way, is going to be minus sine of A. And the derivative top is going to be the cosine. And what does it give you? Well, as you go to pi over 2 from the left side for cosine, top goes to 0, and the bottom goes towards 1. So we're good to go. What's the answer over here? It's 1. We're good to go to problem 101. Thank you.